A beam of light consisting of red, green and blue colors incident on a right angled prism. The refractive index of red, green and blue colors are 1.39, 1.424 and 1.476 respectively. Which color will undergo total internal reflection and which one will emerge out of the face AB of the prism? We have a prism. Let us take a prism, same prism, right angled prism. Right angled prism means this side is 90, this side is 45 degree, this side is 45 degree. This is A, this is B, this is C. And if a ray is passing normal to it means this is normal or this is also normal and this is also incident ray. So angle I, angle of incident is equal to 0. So angle of refraction will be also equal to 0 at this face AC. Now the ray is incident here in the face AB. After refraction through, this goes undeviated because it is incident normal to the face AC. The refractive index of prism for which the ray will graze means graze the face AC, graze the face AB will be from when any ray is falling and it should graze like this face. In that condition, we have studied from the total internal relation for that reflex sine of angle of incident should be equal to critical angle. Should be is equal to 1 by mu r. Mu is equal to 1 by sine C, where C is equal to critical angle. Now what is the angle? And when it is falling like this is 45, this is 45, and if we draw the normal here, this is normal, this is 45, this is 45, so obviously this will be 90. So it is falling at 45 degree and this angle between this line and this line is 90 degree. Since it is 45, this will be 45. If it is 45, angle of incident at face AB is equal to 45 degree. Since angle of incidence is 45 degree, the refractive index of the prism for which ray will graze the face AB will be mu is equal to 1 by sine C, where C is equal to angle of incidence at face AB, which is equal to 45 degree. So it means in that case the refractive index is equal to 1 by sine C. C is equal to I. We can say I, where I is equal to 45 degree. At this angle of 45 degree, C, sine of C, you can write the sine of C, which is equal to 1 by sine of angle of incidence, where angle of incidence should be equal to critical angle for which the ray will graze the face AB. So 1 by sine 45 is equal to 1 by root 2 is equal to root 2. So therefore refractive index of the prism material is equal to root 2 is equal to 1.414. The value of root 2 is equal to 1 by 414. Now the light rays are coming. What this is green ray. First is red. Red is following. This is A, B, C. So it's following. It's refractive. If the refractive index of ray is equal to 1.414 or greater than 1.414, then total internal reflection will take place. We know the refractive index of red is 1.19 for red. Refractive index of red is equal to 1.39, which is less than 1.414. It means the red, the minimum refractive index should be 1.414, for which total internal refraction will take place like this. So if this is 45, these both are 90 degrees, this will be also 45. If total internal refraction means whatever the angle of incidence, the same angle it will be reflected back, so the ray will go like this. Otherwise, the ray can go out. It means the refractive index of the red light is 1.39 and hence less than the refractive index for which the TR to take place. Therefore, it will emerge out of the prism. Now, for the green color, the refractive index is equal to 1.424. So it is greater than 1.414, therefore it will undergo total internal reflection. This is emerge out of phase AB. Then the blue which is got 1.476. .476. So it will also undergo total internal reflection. Therefore, the total internal action if the incident angle at the phase AC is equal to or greater, if it is I is less than C, that is incident angle at the phase AB is less than C, it will emerge out. If the incident angle is equal to C, then it will increase. If incident angle is greater than C, then total internal reflection will take place, where the condition given is sine of C is equal to 1 by mu. So here the refractive index for which the total internal reflection to take place is 1.414. If the refractive index of this much, then TR will take place. And any refractive index, value of refractive index less than this value will emerge out, and equal to this one or greater than this one will undergo total internal reflection. The refracting angle of a prism is E, and refracting angle of prism is E, and refractive index of prism is cot E by 2. Find the angle of minimum deviation. This is a prism. You can take this is a prism. E, side AB and side AC, this is angle of prism. So A is equal to angle of prism, and refractive index of the prism is equal to cot A by 2. So where A stands for angle of prism. So we have to find out the angle of minimum deviation. See, angle of deviation is given by angle of incidence at the first phase plus angle of emergence in the second phase minus angle of prism. So here for minimum deviation, I should be equal to E, and R1 should be equal to R2, which is equal to R, and E is equal to angle of prism. It means I1 R1, so we can write it as angle of minimum deviation. This will be I plus I minus E. Or we can write it as refractive index of the material for minimum deviation is equal to sine of angle of prism plus angle of minimum deviation divided by 2 whole divided by sine of angle of prism divided by 2. As it is given, mu is equal to cot A by 2. Since mu is equal to cot A by 2, we can write in place of mu, refractive index, cot A by 2 is equal to sine of A plus angle of minimum deviation by 2 divided by sine of A by 2. So we take it to this side. Cot of A by 2 will become cos of A by 2 divided by sine of A by 2 into sine A by 2 will go here, sine A by 2, which is equal to sine of A plus minimum deviation divided by 2. So these and these get cancels, therefore cos of A by 2 is equal to sine of A plus minimum deviation divided by 2. So if here is sine, here is cos. So cos can be converted into sine. How it is? See, in the first quadrant, sine of pi by 2 minus theta, where theta is equal to A, will be equal to cos of pi by 2. Cos of pi by 2. Cos of theta. So we can write it as sine of pi by 2 minus A by 2. Sine of pi by 2 minus A by 2. So sine of pi by 2 minus A by 2 is equal to sine of A plus minimum deviation divided by 2. So we can cancel out sine and sine. It means A plus OM by 2. This is equal to this one. That is pi by 2 minus A by 2. Multiplying by 2 both the sides. Multiply here also by 2, here also by 2. This will become 2 into A plus M by 2 is equal to 2 into pi minus A divided by 2. This get cancels, therefore A plus maximum deviation is equal to pi minus E, or angle of minimum deviation is equal to pi. When the A goes that side, that will become 2A. A minus 2A. Or angle of minimum should be equal to pi equal to 180 degree. Pi radian is equal to 180 degree is equal to 2A. The angle of prism is A. That is a prism. Its angle is A. Angle of prism is A, and one of its on one of its refracting surface is silvered. So it means this silvered portion behaves as a plane mirror. So rays will not go out of it, it will get refracted back at any angle. Its refracting surface is silver. Light is falling at an angle of incidence 2A. It means angle of incidence is equal to 2A. 2A, the incidence on 2A and the first surface. We can say first surface A, B is the first surface and AC is the second surface. The light is falling at an angle of incidence of 2A on the first surface, returns back through the same path return back through the same path after suffering reflection at the silvered face. At the silvered face. This is the silvered face. Find the refractive index of the prism. It means there is a ray incident at an angle. This is the ray incident at an angle for this normal. And this is normal. And it falls like this at the silvered face. Silvered face means it has, and it follows the same path. It is following the same path means what? The light should fall normal to this plane mirror, that is silvered face, then only it will come back with the same angle. So angle of incidence should be equal to 0, so that angle of reflection will also be equal to 0. It means this becomes normal to the surface. This is ray falling perpendicular, that is normal to the plane of the mirror. Then it returns back. It returns back and follows the same path back after reflection. So if this is 90 degree, this angle, this is 90, A, this will be 90 minus A. So that the sum of all the three angles, 90 minus A plus 90 is equal to 180. And this is the angle of incidence. Angle of incidence means I, which is equal to twice the angle of prism. And this is the angle of refraction, that is, this is 90 minus A, this and this are 90 degrees, so this is 90 minus A, this certain obviously this will be E. Because this and this are normal perpendicular. If it is perpendicular, then if this is 90 minus A, remaining portion will be 90 degrees. E. So, angle of refraction at the first phase is equal to, in this phase I is equal to 0, R is equal to 0, so that it comes back, follows the same path back. So R is equal to E. So we know mu2 by mu1 can be taken as refractive index of the prism, refractive index of the air is equal to mu. Applying Snell's law at phase AB. Snell's law, phase AB. When we apply, it means sine of angle of incidence into refractive index of this medium. So we can say mu1 and this is mu2. So refractive index of the first medium into sine of angle of incidence is equal to refractive index of the second medium into sine of angle of refraction. Or we can write mu2 by mu1 is equal to mu2 by mu1 is equal to sine I by sine R. Sine I by R, that is sine I. Sine I is equal to sine 2E divided by sine R is equal to sine of E. Therefore, mu2 by mu1 will become mu is equal to sine 2E can be expanded using trigonometry. 2 sine of E into cos of E divided by sine of E. So refractive, this get cancels. So this becomes twice cos of E. Therefore, refractive index of the medium is equal to twice of cos of angle of prism. Is equal to 2 into cosine of angle of prism.